All right, ladies and gentlemen, and here we go with today's class. Today we continued to discuss solving systems of equations algebraically. More specifically, we talked about using the elimination method, and we have a story problem. And we also talked about how to solve or what to do when we have systems that have many solutions or no solutions. So that being said, guys, this third example is actually on page 162 of your textbooks, and it's a story problem. So I'm actually going to go ahead and read the story problem to you guys. Let me go ahead and move this bar over here, and hopefully what that'll do is give me a little bit reading space. All right, so the problem says, to raise money for new uniforms, your school sells silkscreen t-shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8 each. Long sleeve t-shirts cost the school $7 each and are sold for $12 each. The school spends a total of $2,500 on t-shirts and sells them for $4,200. How many of the short sleeve t-shirts are sold? So when we have a story problem, the most important thing that we want to do is highlight or write down the information that we have. Now we know that the short sleeve t-shirts cost the school $5 and were sold for $8. And we know that the long sleeve t-shirts cost the school $7 and were sold for $12. And we know that the school spent a total of $2,500 and they sold for $4,200. So the question, the next thing once we write the information is to find the question. And I actually underlined the question here. And it says, how many of the short sleeve shirts are sold? So we want to know how many of the short sleeve shirts are sold. And basically what you can do, and in class, when I explained this example, what I did was I used S for short sleeve and L for long sleeve as my variables. In this video, I actually went ahead and did what your book did. That way, when you're reviewing the video for your test, you'll have an idea of what was done. And then these two examples that are over here, are example number 4, and we'll talk about those later. So these two examples have nothing to do with this. Now, when we look at the information, we actually have two equations that are set. We have 5x, 8x, 5x plus 7y, X representing the short sleeve t-shirts, Y representing the long sleeve t-shirts, equals 2,500 because 2,500 is how much the school invested. So basically the first equation is giving me the cost, the cost to the school. The second equation is giving me the equation for how much money they earned and how much they sold the t-shirts for. And they're saying that the short sleeve t-shirts were sold for $8 and the long sleeve t-shirts were sold for $12 and the school made $4,200. So what I want to know is how many short sleeve t-shirts were sold. Now I want to know how many of these were sold. Now here's the thing, when you have a system of equation that has two variables, you can't find one without the other. In other words, we have to find one of the variables in order to find the missing one. Now, we talked about solving systems by substitution. We're talking about solving systems by elimination. The reality is that you could use either of the two methods to solve the system, be it substitution or be it elimination. I'm going to use the elimination, number one, because that's what your book used, and so that there's a consistency with what you have in your book and what you see in the video. And the second reason is because if I were to use a substitution method, I'd probably have to solve one of these two equations for either X or Y, and that can make my process longer. So what I want to do is I just want to find a common multiple between any of the variables and then just basically multiply and either add or subtract. So let's look at the equation. Now, if I look at 5 and X, is there a common multiple? And what I mean by multiple, I mean the number that when I multiply 5 by will give me the same number as when I multiply 8 by. And I know that sounds confusing, so let me just show you, and it's easier. What you want to do, one of the methods that you can do to find a common multiple is just use the multiples of your times tables. For example, 5 times 1 is 5. 5 times 2 is 10, 15, 20, 25, 30, 35, and 40. So, and we'll do one more, and 45. Now I want to do the same thing for 8. So I know that 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And 8 times 5 is 40. And I don't need to go beyond that because I realize that 8 and 5 have a common multiple, which is 40. 40 is a common multiple for 5, and 40 is a common multiple for 8. So let me go ahead and underline them. 40 is the common multiple. It's a common multiple for 5, and it's a common multiple for 8. So that means that what I'm going to do next is look at each equation. Now, I remember that I want to cancel them out. So one of them has to be positive and one of them has to be negative. The reality is it doesn't matter which of the two are positive and which of the two are negative, because you're going to get the same answer regardless because it is a linear system. So I, however, am going to keep using or doing what your book did just to not create any confusion when you watch this video and review the lesson in your book. So what I'm going to do is I know that 5 and 8 have a common multiple, which is 40. So 5 times, the question I want to ask myself is 5 times what number equals 40? Well, we know that 5 times 8 equals 40. And 8 times what number equals 40? We all know it's 8 times 5 that equals 40. Okay, so what I want to do is I want to multiply them in a way where I can cancel the equations out. So the first thing I want to do is I'm going to take my top equation and I'm just going to multiply 8 times 5. Okay, I'm going to multiply 8 times 5 because it's 40. But because I want to cancel them out, I want to be able to cancel them out. Instead of using positive 8, I'm going to use negative 8. So we're going to say negative 8 times 5x plus 7y and I realize I didn't write the x here, so let me do that now. 5x plus 7y equals 2,500. So let me go ahead and do that. And that way, what I'll do is I'll have the equation that I am in fact going to use to cancel this out. So let me go ahead and do that. And if you multiply negative 8 times 5, that's going to equal negative 40x. And if you multiply negative 8 times 7, that is going to equal negative 35y. So right here, negative 40x. I'm sorry, 8 times 7 is going to equal negative 56y. So negative 56y. And if I multiply 8 or negative 8 times 2,500, that is going to equal to 20,000. So I have the first one. Now I'm going to look at the second one. So if I multiply the first one by negative 8 and I want the equations to have opposite signs, that means I'm going to multiply the second equation by 5. So here what I'm going to do is I'm going to say 5 times, and then you have 8x plus 12y plus 12y plus 12y equals 4,200. So let me go ahead and write that 4,200. Okay, so now we're going to multiply the second equation by 5, all right? So we're going to multiply then 5 times 8 is 40, and I'm actually going to write it down here. So, you know what? No, 5 times 8 is 40, 40x. And 5 times 12 is 60, so that would be 60y. And 5 times 4,200 is actually 21,000. Okay, so I have that. Now what I'm going to do is just align both equations so that way I can solve and find the missing variables. So that means I'm going to take negative 40x plus minus 56y, which I realized I didn't write, minus 56y equals negative 20,000. And I'm going to add that. And why am I going to add? Because if I'm adding opposite signs, that means that the variables are going to cancel out. So plus 40x plus 60y, excuse me, because this is positive, equals positive 21,000. And now I can solve. So what I'm going to do is just eliminate and then find in the value of the missing variable. So negative 40 plus 40 is equals 0, where it cancels out, and there's nothing I'm going to do with it. Negative 56 plus positive 60 is actually going to be 4y. And then 20,000 or negative 20,000 plus 21,000 is actually going to equal to 1,000. And next, what we're going to do is we're going to divide by 4 so we can find the value of y. So we divide by 4. And y is actually going to equal 250. So according to this, 250 long sleeve shirts were sold, and that's okay, but that's not what I need. I need to find out how many short sleeve shirts. So that would be the value of x. But in order to find x, we need the value of y. So we know that there were 250 long sleeve t-shirts sold. Now we want to find out how many short sleeve t-shirts were sold. So what we're going to do is we're going to take that value, and I'm going to go ahead and erase this and actually plug it in to one of the equations. So let's see if I can erase this and I can have the space I need on this side. I'm actually going to use a different color for that last step. So in order for me to find out what I need, I have to simply plug in the value. So what we're going to do is we're going to take the first equation. I can take any of them, but I'm going to take the first one and say 5x plus, instead of writing 7y, I'm going to say 7 times 250, because that's the value of y. And of course, it's going to equal to 2,500. Actually, let me erase that. I think I can write it closer and I think I can do it here. Okay, so let's try that again. So I'm going to say 5x, but instead of saying 7y, I'm going to change the value of y to 250 because that is what I obtained for the value of y, plus 7 times 250 equals 2,500. Now I can choose any of them, particularly one because it's a linear system. But in this case, giving it more of a real world application, I can choose any of them because they're asking me for quantity. It has nothing to do with the profits. If it had to do with the profits, then I probably had to use a second equation because that's the one that gives me the information on profits. So basically 5x stays the same. 5x stays the same. 7 times 250 is actually 1,750. And then equals 2,500, which means that I can solve for x, and that is going to give me the answer that I'm looking for. So we simply subtract by 750, or by 1,750, excuse me, on both sides. So we're going to subtract by 1,750. And 1,750. Okay, and what's going to happen is that this is going to cancel out. And I bring down my 5x. And you have 2,500 minus 1,750. And that's gonna give me the answer. So just to double check, when you subtract 2,500 minus 1,750, your answer is 750. So this would be 750. And the last thing I need to do is divide by 5. So I'm going to go ahead and divide this by 5. And when I do, x is going to equal 150. So this is actually my answer for how many short sleeve t-shirts were sold. There were actually 150 short sleeve t-shirts sold. And that's my answer for example number 3. Now in example number 4, I'm actually going to go ahead and erase all this. Okay, so that's pretty much what we did for example number 3. Now let's go to example number 4. Example number 4 is basically asking me what do I do, or what would the process be if I have two equations that either didn't give me an answer or gave me an infinite possibility of answers. And for this, we're not going to use one specific method. We're actually going to use both methods. So we're not going to use only substitution or only elimination. We're actually going to use both of them. And which one we decide to use is up to our discretion, although I am going to give you some of the tips that I do or that I use to solve or to pick a method for a given set of equations. So this is example number 4, and this example is on page 163 of your textbooks. So what you guys want to do here is observe the equation and to pick what method you're going to use. So the first one says x minus 2y equals 4 over 3x minus 6y equals 5. Now, you can use the elimination method or you could use the substitution method. I choose the method according to the information that I've got. And I mentioned in class that if I look at the first equation, x has no, or the number, the constant in front of x is a 1. So technically, if there's no number in front of this x, we say that it's 1x. But because when you divide 1 by any number, you're going to get the same, it really does not make a difference. So what I'm going to do in this case, or what I do in this case, is that if I have an equation like that, I usually solve by substitution. Now, the reason I'm solving by substitution is because if I look at the entire equation, if I look at the whole thing, I realize that the constant in front of the x is a 1, which makes it easier to solve for substitution. So the first thing you're going to do is you're going to take the x minus 2y equals 4, and you're going to solve for x. And then once I have that, I can plug it into my equation. So x minus 2y equals 4. So what you're going to do is you're simply going to add 2y on both sides. And this is going to cancel out, and I'm going to have that x equals 2y, or 4 plus 2y. So once I have that, I'm just going to plug it in. So I'm going to plug this equation, or this variable expression, I'm going to plug it in to the second equation. So once I've solved this for x, I'm going to take this and I'm going to plug it down here, okay? So what that means is that instead of writing x plus, or 3x minus 6y, I'm actually going to say